Right, I think we're going. We've got music. It's pretty quiet. It is almost certainly going to get me copyright struck. Don't care. That's fine. That's what happens because I'm not ever going to make any money from this. So I'd rather have the good music. Actually, no, hang on. Still Woozy definitely had my video completely blocked last time. What have I got? What have I got? Good music. Whatever. Okay. No, I said clear my queue. Thank you. No, stop. Dang it. There we go. All right. Regular good quiet music. So CADNurd's Caltrop. He's got a design that is this neat little cube with one red corner. Oh, it's just highlighted for clarity. But it's got this sort of interesting cross-sectional hole, which I want to do two different ways to show different things. And this Caltrop is going to be, or the points are going to be a little more interesting, but I think it'll still be, like, there's a couple of different ways you could do it, and I want to show multiple different ones because reasons. And I'm just now realizing that, oh, it's going to be tricky to loft that right, but I don't know. I'll show the way I want to do it first. So, the big feature that you can see, can I still highlight? I can, yes. The big feature you can see is the that big vertical hole, and it's still a cube. So we're going to start with just nice and simple cube and circle in it. I'll make this. I'm just kind of guessing at proportions here, but 1 and 1.25 seems about right. Select inside the cube, press Alt Q, makes everything equal. Features, extruded, 1.25. I want the origin in the middle, so I'm going to do midplane extrude. And because I have only two contours, it doesn't treat it as a complicated sketch. It's just like, oh, simple nested sketch. Should be pretty easy. Next up is probably the Caltrops, I think. No, actually, let's do the cut. So because I set it up with the origin in the center, I have a plane already in a convenient place to do a revolved cut. Right through the middle of that. So we'll try that method first. Let's see, I need this to give me my cylinder surface that I'm cutting out. Make that equal, perpendicular, and all that fun stuff. Let's see. I gotta select the midpoint of this line and coincident. Select midpoint, coincident. Need to give this somewhere to end, so I'll just make it. Oops. Nope. Hang on. Coincident. There we go. Okay. And just a wild guess, 0.75 seems about right. It'll look proportionally right, I think. But then we can just do a quick revolved cut, and there's your hole. Looks about right, too. Almost to scale. Now, I don't think this is the way most people would think of doing this in SolidWorks, because it's definitely not a common tool. But you can do a 3D sketch to come up with your triangle base. Make those all equal so that now you can drag them out and it scales. I'm going to come over to this. Oops. Make sure you pick the point. Up and down. If I select all three of those, the other thing you can do is click inside here and not clicking anything in the background. Like you can see it wants to select that edge if I mouse over. Inconvenient, or convenient sometimes, inconvenient in others. But if you select inside of a polygon in a 3D sketch, it'll give you the opportunity to select all of them at once. But now I have all those constrained together, and I can just swing this guy around. This is the way that I did it to get 5 features earlier as well. So pick all those, Alt Q. There you go. There's your equilateral triangle. Just looking at it, like if I wanted to define this for some reason, there's arguments to be made that you want to find it as like stick out from the vertex, or, I mean, in my case, I think the most sensible way is, oh, hey, good to see you. Hi, Dad. Yeah. Have fun in Cabo. Anyway, the clearest way that I can think of in the model for defining this is distance from this corner. So make that, say, a quarter looks about right, or maybe a little more, say 375. Rebuild. That looks a bit big, but you know what? We'll stick with 2.5 for now. Now that we have our 3D sketch, we've got a fully defined like profile for that. And because I'm a dingus and I have 3D sketches, or sketches by default gray on gray parts on a gray background, it's a little bit difficult to see, so highlighted, a little easier. Make sure we're not in the 3D sketch context. Now, boundary bosses. One of my favorite features for really screwy stuff, because you can pick where you want all your edges to be on your part. So I've selected a profile, I've selected a direction. It's like, oh, you want this profile this direction. Sweet. Do the same thing with the next one. This is where some people get lazy and forget to select all their edges. If you do that, and I'll show you what happens if you do. Let's see, evaluate, curvature. If you don't pick all your edges, you don't get flat faces. So now we've got radius of curvature 2 inches, weeble wobbling all over the place. We can come back and fix that pretty easy by just adding another open group in direction 2. So do that, say okay, curvature, now it's all flat. Cool, okay, now we only need to pattern this around and then we've got the whole part, so I'll just do that quickly. Pick this open one in here to give you a nice big continuous, select all the way around. I want 4 instances and I want this feature. Easy peasy, mirror across the top plane, circular pattern. It will grab all the features in the circular pattern, including the seed. I was actually struggling with that a little bit. I thought it didn't pattern the seed and was trying to select both at once. You don't need to do that. It grabs everything in the pattern, including the seed feature. But yeah, there you go. There's, I think, actually if we do Control 7, looks like his caltrops are maybe a little bit bigger, so say like 0.3, but yeah, pretty close. And that's in, what, 8 minutes into the stream. So let's show a couple of other techniques. We'll roll back, let's see, and a little bit further. Or actually, hang on, let's do this in another config. Method 2, method 1, base extrude, and we'll just cut all these into method 1. So now that we're in method 2, looks good from here. All right, suppress all that, start again. What I saw a lot of people doing was creating a plane as a reference in between these two planes. Pretty good way to do it. Gives you a nice flat plane to draw on. I don't think it's quite perfect. My preference would be, instead of referencing those two faces, do, I think, do I still have P bound here? It doesn't work. Show primary planes. I thought I had a hotkey set up to show primary planes, but maybe I don't have it on this install. Anyway, it's a little bit safer to define based on front and right plane, and that gives you something that is guaranteed to always be, or to always exist. So, like, if I change what defines the outer edge of this square, or this cube rather, it doesn't just disappear. So we'll go normal to that, and sketch. I think I do actually want it in the middle of this face, so I'm going to use the middle of that point. And I know my origin's in a good spot, but I actually care about where it is relative to the... Let's see, and whoop, construction. I care where it is relative to the position on that face, so that's more important. Let's call this 0.75. Features, extruded cut, and through all both. Now, this way makes more sense if you care about thinking about it in the way of like, okay, how am I actually going to machine this? You're not really revolving a cut through this. You're not going to like throw this on a lathe and I don't know, think of it as like a turning cut, and you're not really revolving your profile, all you care about is the cylindrical bore. So if you want to just draw one circle sketch instead of like this cross-sectional sketch, and I drew it on the wrong side. Yep, drew it on the wrong side. Okay, hang on. Can fix this pretty easy. Draw a line over here, here, and here. Select these two. Oops, not the face, please, just those two. Make them construction, make them perpendicular. Easy. Exit sketch. Now we're on the right side. I'll hide that plane. So there's your cross hole. This also gives us the ability to, well, I'll even do it in the same sketch. Oh, that's not going to be 45 degrees, is it? It's not. No. But I do need a line here of some kind. So that I can define the projection direction for what is about to be an extrude with probably, oh, I don't know. We'll figure it out. Gotta show this plane because I gave myself an axis, but ooh, I'm gonna do this, but I think there's one other fun way to do it. Can I be some distance? Doesn't look like I can easily pick a distance off this. Just gonna make it kind of difficult. But what I can do is I can make another plane with an offset, say 0.25 or 0.125 even. 1.1875. That looks about right. So we'll hide that plane. Sketch, normal. Comes out at a funny angle because, whoops. Oh, that's because the normal's flipped. That would do it. Flip normal. And that also cancels any sketch if you have one open. But now I've got a plane. Let's make. Am I normal to it? Yeah, I am. It's just a funny looking plane. Let's give ourselves a triangle on the origin. Make it pierce. There we go. And now, no matter where I put this plane, this sketch always stays in... Nope, no, it does not. Hang on. Oh, I don't want it coincident with... What? What's going on here? Oh, it's not 45 degrees. That's what's doing it. I do want to go towards the origin, doy. So instead of being 45 here, well, we'll make this reference just to show what the actual angle is. Display options. Oh, driven. Here we go. Drag that over here. I don't remember why I thought it needed to be 45. It should be, there we go. And see, now that sketch looks correct. So now we can take this sketch and say extruded. Just pick that sketch. Draft. Nope, pick the contour. If you pick a contour, then it starts treating it like a contour sketch, which can get kind of messy. Call that 30 degrees. It's not right. Yep. What? Yeah, okay. The actual side angle of a three-sided pyramid. It's going to be some arctan, a square root of 3, something or other. That's going to be... Hang on. So if those are all equal, I want... Arctan... Clark tries to do arctans in his head. Regular triangular pyramid base angle. Arc cosine 1/3. sure that's face edge facing. Cool. Dihedral angle, arctan or arctan 2 root 2. That sounds right. So we'll do that. Features. Not 30 degrees, but 90 minus a tan 2 times square root 2. Nope. It was 8 cosine, I think, of 1/3. Opposite of our hypotenuse. That sounds right. 90 minus 8 cos. Oh, I think it's arc cos actually for some reason. Why didn't it change it? Oh, it's the same. What if we just say like 20? I could do the math to figure out how to make it exactly right, but kind of not feeling it. And you know what? That's pretty close. Hang on. Why is it? Is it giving it to me in radians? It is giving it to me in radians. That's why it's so messed up. 90 deg minus arc cosine 1/3. Nope, still wrong. Goodness. Okay, pi over 2 minus pi over 2 rad minus arc cosine 1/3. Hey, wouldn't you know it? Only took me several tries. Okay, so now we can hide all this. And then, you know, as usual, circular pattern, get the rest of it. I'm just now looking at this and thinking, I think there might also be another way. So, skipping out on doing the rest of the patterning, we'll call that method 2. 3. Suppress. Well, actually, hang on. Let's unsuppress this. Because I still want to have a cut there. I think you could do a corner chamfer. Yeah, you totally can. Equal distance. Please all be 0.25. Don't be ridiculous. Yeah, all that effort. Totally pointless. Convert entities, features, extruded. Draft. Call this. Whoops. No, hang on. I need to do it down here. Pi over 2 rad minus arc cosine 1/3. I feel like I could just figure out. Maybe is it arc cosine of 3 over 1? Whatever. No, it's gonna be arc. So it's 1, 3, and then some other number. I should definitely know how to do this. Whatever. 90 minus is good enough. But hey, wouldn't you know it? One quick chamfer. There you go. There's your point. And this one's even got right side faces. So add to new folder. 3. All that good. Let's see. Well, let's move you below method 1. Below plane 1. We'll keep those as the shared ones. Oops. Method 2 and 3. Whoops, something got made transparent. So we'll just quickly copy the circular patterns from earlier. And vertical mirror. Top plane, easy. Oops. And top. Hang on. Yes, I already got the feature. Nice. Control Shift Q, rebuild everything. I'll just shuffle things around in the tree a bit. Yep, cool. Method 2 and 3. Actually, let's just drag this down a little bit. It's easier to see. So if we go to method 2, whoops. It's a little bit smaller just because 0.375. There's your other config, and there's your other config, and all basically the same geometry. It'll always be a little bit trickier in this one, I think, because you can't as easily control your depth. Like, you'd have to add an equation in order to make that controlled as distance from the point. Frankly, method 3 is probably the cleanest for producing that. Method 1 with the boundary, like, it's exact, it's easy, you don't have to have equations, but I can almost certainly guarantee that it takes longer to rebuild. So actually, let's do that. Rebuild method 1, 0.27. Method 2, 0.08 for the method with the extrudes. And then 0.3, evaluate 0.08. Yeah, so the boundary boss is, I mean, we can even go back and look at that if we, let's see, mirror. Oh, that's weird. Oh, you know what it is? The mirror and the circular patterns are not geometry patterns. So if I come in here and go to the circular pattern and say, hey, don't rebuild this feature from scratch every time, just duplicate it. And then do the same thing in the mirror, do a geometry pattern. That will crush my rebuild times. Performance eval, refresh 0.11. I bet if we go to the other ones, it'll have similar performance benefits. So let's go, nope, not the whole, but the circular pattern. Well, beforehand, we can check that too under performance eval. 0.08, mirror and circular pattern take the longest, so we can probably get this down to a part that takes a 20th of a second to rebuild. And keep in mind, these numbers are not exact. This is my machine, this is not your machine. I have 16 cores, 32 threads, and firepower to spare, so. Method 3, circular pattern, edit feature, geometry pattern, oops. Same thing in the mirror. Evaluate performance down to 50 milliseconds, and if we go to method 2, I bet it'll be similarly, like, a similarly large performance improvement. Yeah, so boundary bosses, not your friend from a performance perspective, absolutely your friend from like a simplicity and exact control perspective. I think probably the chamfer method is the cleanest here, but I don't know, there's something to be said for having a really specific like set of planes calling things out and, you know, offsetting things and having more features to let you control things more carefully. There's definitely benefits to that. Don't ever let anyone tell you otherwise by saying you should always be part golfing, because I did this today. I designed a little bracket that had a thin extrude, and when I realized that I wanted to have, well, I could just draw it up real quick. Say you've got this part. Let's do it on the top plane. Say this is like 30 millimeters long, and this one up here is 70 millimeters long-ish, or even 100. Features, extrude boss, 10, 20, plane, 20. So you've got this part. You've got this little bracket you've designed, you're like, oh, sweet. you've spent half an hour adding features to it, holes on this side, a nice chamfer here, stress relief in there, and some chamfers on the corners. And then you realize, wait a minute, I want to control the thicknesses of these two faces differently. You can't just go into the sketch for the thin extrude and say, hey, give me offset entities, don't make anything construction, cap ends with lines, say 20. Delete that offset, and then just do these. Oh, it's done the offset thing, so I gotta remove that first. Remove that offset. There we go. Now I can control these independently, but exit sketch. Now it's just gonna do weird stuff. Like I can no longer control it. If I want it to be just on the inside, unable to make feature as specified, and you can't undo the thin feature. So you have to X out. You got to delete the thin extrude. You got to go in here, make sure your sketch is all good to go. Well, it looks like those actually aren't perpendicular, but that's pretty easy to fix. There. Now we're fully defined. You have to remake it with a new boss feature. Honestly, if Solidworks could do anything, Dasso rather, I'd really like them to make it so you can disable thin features after the fact. Like, even if it breaks things, even if it's going to cause problems, anyone who's disabling a thin feature after doing it probably knows what they're doing. So, you know, gotta stand on my soapbox every once in a while. But anyway, back to the matter at hand. CADNurd's Caltrop. Fun little part. Lots of interesting, different ways to do that. If you're still watching, thank you. To anyone watching this later down the line, hope you liked it. You know, like or subscribe. I don't mind either way. It really doesn't make a difference to me. I'm just happy people are learning. So, let's pick method 3 to save it as. By the way, it does matter which configuration you save things in. That's what shows up to people. If I save this and then close it and then say open recent Caltrop, it'll reopen with the same config and the same view orientation. If someone else saves it and you check it in, or if you open it up in PDM and change the orientation and save it, check it back in, then it'll have a different orientation on reopening. So, but isometric is best. Save. Yeah, that's all I've got. Have a nice morning, afternoon, evening, or night. Yeah, thank you. Bye. Boink.